Putting things into scientific notation and standard form have really specific rules. So I want you to grab your notes at this time, and then you're going to go ahead and write these rules down. I'm going to read them to you, and at any time if you need to pause the video so that you can copy them down, go ahead and do that. We'll also run through a couple of examples from your worksheet on page 336. So I'll refer to some problems from that page, and I'll do some of the examples with you guys. Okay, so first of all, there's 3 rules for scientific notation, and I'm going to be using the example of the number 1 million. The first rule is that you can only have a single digit in front of the decimal point, and it cannot be a 0. So you can have a 1, 2, 3, 4, 5, 6, 7, 8, or 9, and that is all. So when we move the decimal point, we're going to be moving it so that there is only one of those numbers in front of it. And that means if we were moving a decimal point for the number 1 million, we would want a decimal point that landed right here after the 1 in 1 million. The second rule is the number will be multiplied by a base of 10. Now, the base of 10 is a standard. It means that you cannot have a base of 8, you can't have a base of -5, it will always be a base of 10. So we take the decimal that we had just moved, 1.0, and we multiply it times a base of 10. Because what it's going to do is replace all of the zeros that we just got rid of. The last thing is that the base of 10 is always going to be raised to an exponent, and this exponent is an integer. Now remember, in the last unit we learned that an integer is only a positive or negative whole number. So it can be a positive or negative whole number answer. It can't be a variable, it can't be a decimal, it can't be a fraction. So, for example, when you have the number 1 million, you are moving the decimal point from the end of the number to after the 1, and we moved it 6 spaces. So your new number in scientific notation is 1.0 times 10 to the 6th power. So go ahead and go to your work packet because we're going to do a couple of examples, and numbers 3 through 8 are asking you to tell whether the number is written in scientific notation or not. So we're just going to go ahead and do numbers 3 and 6 for examples. If you look at number 3, they have the number written as 17 times 10 to the 15th. Well, the problem here is 17 is a double-digit number. Remember, rule number 1 says that the number in front of the decimal would have to be a single-digit number, either numbers 1 through 9. So for this to be written in scientific notation, it would have to be 1.7. So this is not in scientific notation, and that would be why, because 17 is a double-digit number. Or if you look at number 6 is written as 0.999. The reason that this is not in scientific notation is because the decimal point would actually have to be after the first 9. Remember, 0 cannot be in front of the decimal point. So this is also no, and you would have to move the decimal so that it is after the 9. Okay, if you look up above at number 1, I want to address something with you guys because there are a few of you that have a calculator that may display your answer like this. It reads 8.6 e to the negative 10. All I want you to do right now is I want you to rewrite this number as 8.6 times 10 to the negative 10. Because what I'm going to tell you is what this means is that this e is actually replacing in a calculator the base of 10. Some calculators, that is how they display it, but that is actually what it means is the base of 10. Before we do this problem, because what it's asking you to do is write it in standard form, we have to go back to your notes and write down the rules of how we turn scientific notation into standard form. So let's go ahead and do that first. All right, so first of all, in order for us to put something from scientific notation into standard form, you have to know that all whole numbers have a decimal after them. All we're going to do is add the decimal back in when we don't see it. So for example, 5 times 10 to the negative 4 does not have a decimal after it. What we can do then, if we need to turn this into standard form, is we're going to put the decimal after the 5. All a decimal means after a whole number answer is that it is a terminating number. Next, we're going to circle the exponent. The exponent, if it is positive, means that we are moving the decimal to the right. If it's negative, it means we're going to move the decimal to the left. In this case, on this particular example, we have a negative exponent, so we are going to be moving our decimal to the left. It says that we have a negative and it says we have a 4. We are going to move it 4 spaces, 1, 2, 3, 4 to the left. Now, we have 3 spaces in front of the 5 that have nothing there. You are going to fill those in with zeros. The last rule says we are going to drop the base of 10 because you no longer need it. So when we write 5 times 10 to the negative 4 in standard form, we now are going to write that number as 0.0005. And that is how you write 5 times 10 to the negative 4 in standard form. If you look at number 10 on your worksheet, let's go ahead and do this now with a big number or a positive exponent. This time, since we have a positive exponent, we're going to be moving our decimal to the right. So we have 1.54. We are going to take our decimal point and we are moving it 5 spaces. Since it is a positive exponent, we are moving it to the right. 5 spaces. 1, 2, 3, 4, 5. We have 3 spaces after the 4 that are empty, and we fill those in with zeros, which means we now have the number 154,000. We can leave the decimal point at the end of the number, or we can drop it off. Most of the time, you don't see a decimal after a whole number answer anymore because we just drop it off. Now, let's return to number 1 at the top of your page. Remember, we had this 8.6 times 10 to the negative 10. Let's go ahead and turn this into standard form. We have a negative number. We are going to write 8.6, and we are going to move this decimal 10 times to the left because of the negative. 1 time around the 8, and now 9 more times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we fill that in with zeros. I'm going to rewrite this and clean it up a little. The decimal here is no longer here, so we move it to the front. It's a very small number. There are 9 zeros in front. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 8, 6. Okay, so that is how you write 8.6 times 10 to the negative 10 in standard form.